All right, one more standing wave example. A trumpet is a closed air column that can be played at a fundamental frequency in a first and second overtone. On a 20 degrees day, the trumpet plays a fundamental frequency of 256 hertz. Determine the first and second overtones. So what I'm going to do is I'm going to use the frequency provided as the fundamental frequency to determine the length of the trumpet. And then using that length, I will find the first and second overtone frequencies. So first of all, 20 degrees Celsius day. So the speed of sound works out to 344 meters per second. Okay, with that in hand, I'm going to take the fundamental frequency and find the wavelength using the universal wave equation. So that works out to 1.34 meters. Recognizing that I said it's a closed air column, the length can be related to the wavelength through this formula. Since I'm dealing with the fundamental frequency at this point, that means that n equals 1. And so if my length is equal to a quarter of my wavelength, then my trumpet must be about 34 centimeters long. Okay, this isn't realistic. I'm just using these numbers for the sake of this example. Now, let's say that we want the n equals 2. That means that the relationship between my length and my wavelength is now 3/4 of a wavelength. With that in mind, we recognize that just changing the harmonic won't change the actual length of the trumpet, so we can just use the value that we calculated for that. And I get a new wavelength of 0.45 meters. Using the universal wave equation. Again, the speed of sound in air won't depend on which mode we're in, so we'll just keep that at 344 meters per second. And I get a frequency of 768 hertz. One more. So I use the n equals 3. The relationship is that now the length is equal to 5/4 of a wavelength. Again, the length won't change. So I get a wavelength of 27.2 centimeters using the universal wave equation. The resulting frequency will be 1,265 hertz. So, if it plays 256 as its fundamental frequency, the first overtone, or the n equals 2, will be 768 hertz, and the n equals 3 will be 1,265 hertz.